here is 4-5, day 2. I'll get that labeled right up here. The focus is still on sine and cosine, except we're going to add just a couple new transformations. Really, if we want to kind of put it in simple terms, in the first day we did some stretches, and now we're going to do some shifts. Okay? So vertical translation, if you want to kind of relate back to some of the terminology we've previously used, you can call that a vertical shift. It's right there. We call that parameter D. Okay, so anytime you see that in a homework or a quiz or whatever, D is referencing what the vertical shift is. All right, now it's very possible you could come across 3 cosine 2x plus 2. Just know that that's the exact same thing. Okay? Now, one thing about the 3 examples I'm going to take you through today, compared to the first day, they are a little bit harder. Every single example in the first day had 1 transformation going on, at most 2. Here, we could have 4 total. I'm not going to show you one with 4 yet. But everyone will have at least 2, and then take this one, for example. It has 3. And we'll see 2 of them that have 3. So the more we have that's going on, the more it becomes really, really important off to the side. And I probably should have put the outline, because you're obviously much more likely to do this if I put an outline of it. Tests and quizzes will have it, but you really should go through and take all of your transformations and to identify what they are. For example, A, or the amplitude, which stretches the graph out vertically, is 3. The value for B, that's the number that changes the period, is 2. All right? Now we have that formula for period length, which is 2 pi over B. So this graph's period has been shortened down to half of what it was. Instead of 2 pi, it's down to pi. And then, as previously mentioned, this graph does have a vertical shift. It's all bumped up 2 units. And you're actually going to see that is really where I think you should start. Okay? That's where you should start. In every example we've done so far, it was right at y equals 0. Okay, but what I'm going to do now is I'm going to bump up 2 units, and then I'm going to draw this dashed horizontal line, which you can put on there, you don't need to. That line should run right down the middle of our graph, and it should be centered right along that. Okay, and that reflects the vertical shift that it's bumped up to. The reason that's concerning for me is because we didn't see that in the first day, so every time that horizontal line was at y equals 0. That'll become a big deal when we get to the amplitude. Okay, because how high and how low the graphs is going to be a little bit different. Okay. I should put a scale on here. We'll do 2 periods. Homework problems make it really clear as to how many to do. Let's do 2. Okay. Now let's get to our amplitude. Okay, when from what the examples you've seen so far, if I say the amplitude is 3, you probably think, okay, the graph is going up to 3 and down to -3. And that has been true if we don't have a vertical shift. And now we do. Okay, so what you want to do is go from that horizontal line, which would be 3, 4, 5. My graph is going to go up 5 units from there I've already got 1, there's 0, there's -1. Okay, so it's really going to go between -1 and 5. All right, and that's because of the shift. The way to think about it is if you have that shift marked at y equals 2, okay, where 3 comes into play is we're going 3 units up and 3 units down, but we're starting at 2. Okay. All right, we're in pretty good position now here to make our graph. It's a cosine curve. It's going to start up here. I should be back up there by pi. And I should be back up there again by 2 pi. All right. Down at -1, that should be halfway in between. At pi over 2, we should be all the way down there. And over here at 3 pi over 2, we should be down there. Whoops, that was a little bit too far. Probably the easiest thing is just going to be to adjust how far I put down -1. I'm losing my scale here a little bit, but that point should be right at -1. I drew that too far down. But that'll work. All right, then right in between here, you don't have to mark these because the graph would be getting a little bit cluttered. But that would really be at pi over 4 and 3 pi over 4. That's where we should hit y equals 2. And that gives us enough of a pattern here that we could go through and sketch our cosine curve. There's period 1. And there's 2. Okay, there's our first look at a trig function that had 3 transformations, and also our first that had a vertical shift. All right, this one only has 2 going on, but we now have, and again, if you would like, you see vertical translation. If you want to read that and think, okay, vertical, or excuse me, horizontal shift, you could. That is right here, and it's what we call C. Okay? So let's get right to work with all of our parameters here. I look at that equation and I see, hey, the amplitude is 1/2. B, I'm always looking right in front of the x value, and I don't see anything, so it's 1, which means the period of this graph it's unchanged, right? The amplitude has been changed. It's got a horizontal shift, but notice these other two. B is just 1, and then it doesn't have a vertical shift either. And again, that's why I think it's so important that you go through and do that before you start to graph, so you kind of get the big picture of, you know, with this particular sine curve, what is going on? What has changed from the parent function and what hasn't? Okay? So now right off the bat from what I see, now here's the thing. I want, you know, I see that the period is 0 to 2 pi. Okay? But I'm actually not going to mark that, and it's all because of this. This is our first time seeing it. This graph has been shifted pi over 3 units to the right. And it's, you know, if it's happening in a particular problem, it's an extremely important number, okay? Because it tells you a lot. The biggest thing as far as, we're just going to sketch one period of this graph, but that pi over 3 is going to tell us where to start, okay? Normally that would be at 0, okay? However, I'm going to go just a little bit to the right, and I'm going to start at pi over 3. Okay, now one thing I should draw in here, let's do the y-axis is a little bit more straightforward. I drew it going from -1 to 1, but obviously this one is just going to go. to a half and negative 1/2. So now, typically we would end at 2 pi, but the same thing is going to happen is that this has to get shifted once again. Like every single x value has to get shifted pi over 3 units to the right, which means it's going to end there. Okay? Now a little hint as to how I got that. You do have to do a little bit of work with some fractions. Okay? 2 pi is the same as 6 pi over 3, and then I just added on that pi over 3, our horizontal shift, and that's where it should end. Okay? Everything's getting bumped to the right. By the way, this is probably worth an explanation here. This does what horizontal shifts always do, where you see the minus pi over 3, and you think that it's going to get shifted to the left, but it ends up going to the right. We've seen that before this year many times, but that's always what horizontal shifts do. They always do the opposite of what you think they're going to. Okay? Now I'm going to go ahead and split it into fourths. Halfway in between. I could just average those two at this point. These numbers aren't super nice to work with, but that would be 4 pi over 3. And then if I did it again, if I averaged pi over 3 and 4 pi over 3, we'd get 5 pi over 6. And then 11 pi over 6. Okay? So if you see where it starts and ends, then you could just basically do the midpoint. You know, take the average of your endpoints there 3 times to get it split up into fourths. And now we're pretty much good to go. Right? Again, that pi over 3, stick to that, as that tells you where it starts. 5 pi over 6 will be up at a half, back to 0. At 11 pi over 6 will be down at negative 1/2. And then back to 0 at 7 pi over 3. And there you have it. There's one period of that sine function that has a change in amplitude. Notice it only went up to a half and down to negative 1/2. But that's the first time we've seen a horizontal shift. All right, here is the last one we're going to do, and then I've got a slide next that's going to kind of summarize all the stuff that we went through, like all 4 transformations. Okay? Now I'm going to start over here getting into amplitude. And you may notice that I'm just going to say that it's 3, okay, which is okay, though I am making note. You see how there's a negative sign in front of negative 3? Okay, this is going to have a reflection. All right, the other thing I'm looking at here is this is a cosine curve. So realistically, what does that negative sign mean? All it means is when we start to sketch this, instead of starting at the top, we need to go down and start at the bottom. Okay? That's really what it's about. But if I remember to do that, I can just say that the amplitude is 3. Okay? Let's get into B. Interesting here. B is 2 pi. We haven't seen this before, but we're actually going to see it a whole lot more. Okay? B is 2 pi. So following our formula, 2 pi divided by 2 pi is 1. Okay, it seems kind of interesting to put in a value in for B that's a multiple of pi, but that does something that's pretty significant. It's going to take the period and switch it to something that's not a multiple of pi. And you'll find in application problems that's very often something that we want to do. So whenever you see that, that's what's going on. All right, C, we got to talk about that because this is a tricky one to find C. Luckily, D is 0. There is no vertical shift. Okay. So on that note, with the vertical shift, let's go ahead and get our y-axis squared away. We got to go 1, 2, and 3. That's based off the amplitude. -1, -2, and -3. Okay? All right, I'm going to show you a formula on the next slide here. This is all about C. That basically, if you want to look at C in terms of the horizontal shift, it has to be written like that. Okay? Which basically means, and again, C is a really, really huge number because this graph has been shifted from side to side or in the horizontal direction. C will tell me, as far as like period number 1, it'll tell me where to start. And it's not going to be at 0. So I got to figure out this value. And if you look at that, as it's written in the equation, it's really tempting to say that C is 4 pi. And it's not. Okay? It's not 4 pi. Because that expression in here needs to be factored if you want to directly observe C. Okay? So here's the case that we have is 2 pi x plus 4 pi. Now, if you were to just look at that, remember how it does the opposite. So we see that C would be negative 4 pi. So a common incorrect answer is to say that, and it could be either right or left, I guess, to say that C is 4 pi and you're moving 4 pi units right, or negative 4 pi and you're moving 4 pi units left. Neither of which is C. Okay? Notice they both have a factor of 2 pi. Okay? Which leads to that. Okay? If you want to convince yourself that that's true, go ahead and distribute the 2 pi and you should be back to what you started with. Okay? Now I'm starting to be able to see our value for C. Now keep in mind here, it should follow this formula. So really what's going on here is it's always minus. So because it's plus, you could think about it that way. That it's really x minus negative 2. And we have finally uncovered that C is negative 2. All right? That means a shift of 2 units left. But the really big deal is it's telling us to start at negative 2. Like in terms of your x value, that is where you should be starting. Let's go to negative 1. I don't want this to get too cluttered. I'll put the halfway points here, and that's all I'm going to put. Now I'm going out to negative 2 and 2. So I'm actually going to set us up. We're going to draw 4 periods of this graph. Okay? We're going to draw 4. Remember, cosine needs to start down at the bottom, and we go to negative 2. So the first point I'm going to put is going to be way down here. That's where this is all going to start. And now I'm just really going to use the period of the graph, which is 1. So if I go to negative 1, I know I should be back at my minimum. And then 0, I should be back there again. And at 1. And at 2. Okay? If I go halfway in between, like at negative 1.5, that is where I should be up at my max. Same at negative 1/2, positive 1/2, and positive 1.5. Okay? And that's all the more detail I'm going to put. It's plenty to get a good sketch here. We're headed up, we hit our max, and we're back down at negative 1. There's 1 period of the graph. Okay, like I said, we're going to do 4. We're up to the top and back. And there's number 3. And there is number 4. Okay? Really, the part of this particular example to pay close attention to was C. We had a little work that we had to do to find C, but it was extremely helpful because that told me over here, like I knew ahead of time with the cosine and the reflection that I was going to start down at the bottom, but where am I going to start for my x value? Finding that C was -2, which really just meant that I had some factoring to do. Okay, make sure that that expression in the parentheses is factored. All right, I got a couple things that I'm going to adjust on this, particularly with the horizontal shift. But this kind of has the basic structure of all 4 transformations that we could do, with a couple little shortcuts that I actually haven't talked about yet. If you want to just get the amplitude, if you somehow just knew the max and the min in the problem, you could get it from there. Max minus min over 2 will get you A. The one in green for the period and B, you've seen that one before. Down here, these would be formulas for where the first period starts and ends. Don't use those. Okay? What you really need to know, okay, about C is C will tell you exactly where to start, and if you can factor out B, you need to do that. Okay? You need to do that. And always remember, too, whatever you're seeing in the equation, like in the last example, we saw that it was x plus 2. That means C is -2. Had it been x minus 2, that means C would have been +2. That it does the opposite. Horizontal shifts always do that. D, no, that's not a typo or anything. That's how similar it is. If you do max minus min over 2, you will get A. If you do max plus min over 2, that will give you D. Okay, I'm just kind of showing you these now because when we get to section 8, we're going to actually use these a whole lot more, and especially the first 2 to convince you that they're correct. In time later on in chapter 4, we'll do that.